So in this problem, we are told that a family has 4 children, and we are asked to find the probability that the oldest is a girl and the youngest is a boy, given that there is at least one boy and at least one girl. So we can visualize our entire sample space for how the family could be laid out with the following tree diagram. So we have 4 different levels. We have levels for the first child, levels for the second child, the third child, and the fourth child, so that we have a total of 16 different possibilities for all the possible ways the family can happen. So now, if we are interested in the fact that the oldest is a girl and the youngest is a boy, given that there is at least one boy and one girl, we can come down to only the paths which have at least one boy and at least one girl. And so what we can get rid of then is the path where we have all boys, so that will get rid of that path because we have no girls. We can ignore the path where we have all girls because we likewise have no boys in that situation. And so the paths where we have are these 14 that are in the middle, where we have at least one boy and at least one girl. Now, how many of these paths have the oldest being a girl and the youngest being a boy? Well, if the oldest child is the first child, then if we need our oldest to be a girl, then we have to be along this path. So any path stemming from there will have the oldest child being a girl. And we also need that the youngest child needs to be a boy. Well, how many of those paths that start at that first G and end with a B? We have the path here, we have the path there, the path there, and the path there. And so we have a total of 4 paths that have the oldest child as a girl and the youngest child as a boy. So we have 4 paths with the oldest a girl and the youngest a boy. Okay. So now, if we're interested in the probability that we have oldest is a girl and youngest is a boy, given that there is at least one boy and one girl, then this will be the number of outcomes that we want, where we've already said that there are 4 paths with the oldest being a girl and the youngest being a boy. And then our number of paths where we have at least one boy and one girl are all 14. That we have, where we've excluded the all-girl path and we've excluded the all-boy path. So our denominator will be 14. And so if we kill off a factor of 2, what we have is the probability of that happening is 2/7.